Good afternoon, everybody. This is Mr. Devashish Purohit, going to give a lecture on topic tablets. What are tablets? Tablets are oral solid dosage form with uniform size and shapes that can be administered orally. The definition of tablet is a compressed solid dosage form that contains medicaments with or without excipients. And according to Indian Pharmacopoeia, pharmaceutical tablets are solid, flat, or biconvex tissues unit dosage form that are prepared by compressing a drug or mixture of drugs with or without diluents. They vary in shape and differ greatly in size and weight, depending on amount of medicinal substances and the intended mode of administration. It is the most popular dosage form, and 70% of total medicines are dispensed in the form of tablets. So all the medicaments are available in the tablet from except where it is difficult to formulate or administer. So, what does a tablet here we'll cover what does a tablet contain? That is API, that is drug, active pharmaceutical ingredients. And next is excipients like binders, flavoring agent, coloring agent, all that things we will learn in this lecture. Okay. So, next here's the list of excipients. First is binders, second is disintegrants, third is glidants, fourth is lubricants, fifth is diluent, sixth is coloring agent, seventh is flavoring agent. So now we'll go through functions of different excipients. First is binders. What it does, it ensures that the tablet and granules can be formed with required mechanical strength and give volume to low active dosage tablets. Like it gives a mechanical strength and it helps it to give a volume or give a size or shape to the tablet. So example is sorbitol, mannitol, microcrystalline cellulose. Next excipient is disintegrants. So what it does, it releases the mechanical substance with contact of moisture and absorption. Means it will release the API or drug when it comes contact with the moisture or absorption. So here are some examples like PVP, then carboxymethyl cellulose, pre-gelatinized starch. Next, coming to glidants. Uh, what is the function of glidant? And it improves flow properties. If flow properties of the formulation will be good, then the uh, formulation will give a good therapeutic activity. So there are some examples like silica gel, magnesium carbonate. Okay. So next coming to lubricants. So lubrication is important parameters that can be considered while formulation of tablets. So what does it do? It prevents ingredients from clumping together and it's improve the flow property. So examples is talc, magnesium stearate, all that things. Okay. Next coming to diluents. What does it do? It enhances the bulkiness of the drug and it provides the improved cohesion and it increases the flow properties and it allows the direct compression in manufacturing of tablets. Some of the examples are given like sorbitol, mannitol, lactose, calcium carbonate, sucrose. Next, coming to coloring agents. So, what the function of coloring agent is? It masks up the color of drugs. Uh, in some of the drug, the color is very bad. It gives a good color, and if many batch are manufactured in an industry, and we need to identify the drug. So here identification of drugs is necessary. So here coloring agents can be used. Next, production of elegant product. Production of elegant means good. Production of good products. Here, all coloring agent must be certified by Food and Drug Administration. That is the regulatory body for USA. Next, there are some example like FD&C yellow 5, atrazine, FD&C green 3, fast green. Next, coming to flavoring agents. What does it do? It masks the bitter taste. It provides improved cohesion. It enhances the flow properties. It allows direct compression during manufacturing. So generally, flavoring agents are used to mask the bitter taste. Like we cannot give to a child or a aged person. So taste is a important parameter. So here is some examples like aspartame, saccharin. Next, coming to advantages of tablets. So first is they are unit dosage form and offer greatest capabilities of all oral dosage form for the greatest dose precision and least content variability. So these are unit dosage form which provide a greatest capabilities of oral dosage form for the greatest dose means the dose can be increased and it will provide a good unit dosage form for oral absorption. Next, coming to second point, the cost is lowest of all oral dosage form, and here the cost will be low. Next is lighter and compact. It's light in weight and it's compatible. Third, coming to its easiest and cheapest to package and strip, means its uh, packaging is easy and packaging material is cheap in rate. Next, coming to last point, that is easy to swallowing with least tendency for hang up, means easy to swallow with less tendency. Next, sustained release product is possible by enteric coating. Generally sustained release tablets are uh, produced by coating material that is enteric coated. Next, objectionable odor and bitter taste can be masked by coating technique. So, objectionable odor and bitter taste. So, like we gone through the coloring agent. So here, odor, coloring agent, flavoring agent. Here, the odor and bitter taste can be masked. Next, coming to suitable for large scale production. So, tablet is suitable for a large scale production. It is possible for large amount of production. Next, coming to uh, greatest chemical and microbial stability up over all oral dosage form. So here the stability, that is both chemical and microbial properties of oral dosage form is good than others. Next, coming to product identification is easy and rapid, requiring no additional steps when employing an embossed or monogrammed punch face. So here product identification is easy, like I explained in the previous slide that during manufacturing coloring agents are used to identify the product. So product identification is easy. Okay. So next is disadvantages. It is difficult to swallow in case of children and unconscious patients. For taste or odor, it may be difficult to swallow. Next, some drugs resist compression into dense compacts owing to amorphous nature, low density character. So, due to low density character, some drug that may be amorphous in nature. So compression is a greatest parameter that is required for the drug. Okay. Next, drugs with poor wetting, slow dissolution properties, optimum absorption, high in gastrointestinal tract, may be difficult to formulate, manufacture as a tablet that will still provide adequate or full drug bioavailability. So the drug that is having poor weighting and slow dissolution properties and a good absorption capacity in the gastrointestinal tract, that may be difficult to formulate or manufacture as a tablet. So it still provide a full drug bioavailability. Okay. Next, coming to last point, that is beta testing drugs. Drugs with an objectionable odor or drugs that are sensitive to oxygen may require encapsulation or coating. In such cases, capsule may offer the best and low cost. So, some drugs are bitter in taste. After masking the taste, odor, they are still bitter in taste. So, in case of this point, encapsulation or coating is required. And next, ideal characteristics of tablets. These are the ideal characteristics. Like first, a tablet must be strong and hard to withstand mechanical shock during manufacturing, packing, shipping, dispensing, and use. Second is the content of the tablet must be bioavailable. That is, the tablet must be able to release its content in a predictable, reproducible manner. The tablet must be chemically, physically stable. Means stability should be good for physically and both. Yeah, both physically, chemically. Okay. Next, coming to the tablet should have elegant product identity which is free from any tablet defect. So tablet defect should be checked. Next, the tablet must be uniform in weight and the drug content. So drug content and the weight of the tablet should be uniform. Next, coming to types of tablets or classification of tablets. First is compressed tablets, second is multiple compressed tablets, third is repeat action tablets, fourth is delayed release tablets, fifth is sugar coated tablets, sixth is film coated tablets, and seven is chewable tablets. And next, tablets used in oral cavity. Here, buccal tablets, sublingual tablets, pouches or lozenges, and I can give you example of lozenges like a big chocolate or strepsils. These are lozenges. Okay. Next, coming to dental cone tablets. Here, uh, and next is tablet administered by other routes. First is implantation tablet, that is in case that is used in dental tablets. Next is vaginal tablets. The next step, tablets used to prepare solution. These are the tablets that are used to prepare solution. Simple example is Disprin. So first is effervescent tablets, second is dispensing tablets, third is hypodermic tablets, fourth is tablet triturates. Next, first formulation of tablets. First is it may be formulated for granulations and direct compression methods. First, coming to granulation, one is dry granulation, second is wet granulations. So here this flowchart explains about direct compression, wet granulation, and dry granulation. In direct compression, we use generally first step is drug and diluent and glycine disintegrant. These things are mixed, then lubrication is done, then compression is done, then it is compressed, and then at last that's coating, dedusting, metal check, packaging, all these properties are checked and sent for marketing. Next, coming to dry granulation, here we use drug, diluent, and lubricant. Means here glycine is not used. So after that we mix all that things, then uh, compression is done, then comminution is done, and after communication screening is done, means it's checked whether it is correct or not, and again disintegrant, glycant and lubricant is mixed. After that compression is done, and after that uh, we eject the tablet with the dye. After that different properties like metal check, dedusting, coating, packaging, these all are checked and marketed. Next, coming to weight granulation, uh, here simple thing, lubrication is not done. First drug and diluent are used, then they are mixed, then weighting is done, then binder solvent are used, uh, then granulation is done, then it is dried, then screening is done, means it's checked. After that mixing is done by using disintegrant, glycan and lubricant, then the tablet is compressed, then different properties are checked. Next, coming to some tablet defects like capping, lamination, cracking, chipping, picking, sticking, binding, double, then impression, mottling. Next, these are some problems that are created during coating of tablets. First is blistering, second is cratering. So, what's blistering? It's the local detachment of film from the substrate forming blister. So, what are the causes? First parameters is temperature, which affects on the strength and elasticity of and adhesion of the film. These remedies can be taken like you need to use some mild drying conditions. Second is cratering. So what it does, it defects the film coating. So why film coating is defected? So here some volcanic like craters that are appears uh, during exposure of surface of tablets. So what is the main reason? Inefficient drying, then higher rate of application of coating solution. So what remedies can be taken? We need to use efficient and optimum drying conditions and increase the viscosity of coating solution to decrease spray application rate. Next problem is picking and sticking. So it defects where the isolated areas of the films are pulled away from the surface when the tablet sticks together to the pan or detached from the one pan to another pan. So here sticking like gum, it will stick to the pan where the tablet is formulated or uh, made. Okay, so what are the reason? Inefficient drying, higher rate of application of coating solution. So what remedies can be taken to increase the inlet air temperature, decrease the rate of application of coating solutions? Next, cracking or splitting. So what it is, how it is done? It is the defect, so it is a defect in which the film either cracks across the crown of the tablet or splits around the edges of the tablets. So what are the causes? We need to use higher molecular weight polymers like uh, carbopol 900, 950, like that. Polymers are divided into uh, various types according to their molecular weight. So we need to use higher uh, molecular weights uh, or polymeric blends. So this is the reason for which the cracking or splitting defect comes in the tablets. Next, how it can be minimized? It can be minimized by using lower molecular weight polymers or polymeric blends, and also we need to adjust plasticizer types and concentration. Next problem is blistering. So what is blistering? It is the local detachment from a film from the substrate forming blister. So what is the reason behind this? So reason is effect of temperature on the strength and elasticity and adhesion of the film. So temperature, elasticity, strength and adhesion. These are four parameters which causes blistering of tablets. So what remedies can be taken? We need to give a good drying condition in the formulation of tablets. Next, coming to the problem, cratering. So what is cratering? It is a defect of film coating whereby volcanic-like craters appears exposing the tablet surface. So why discussed? Discussed due to inefficient drying and high rate of application of coating solution. So how it can be controlled? It can be controlled by using efficient and optimum drying conditions. We need to increase viscosity of coating solution to decrease spray application rate. Next, what is tablet tolling? Tablet tooling means high-speed tableting in 24-hour shifts has tremendously increased productivity, which in turn places heavy demands not only on tablet press and compressibility of tableting materials but also on precision with respect to dimensions and wear resistance of tablet tooling. Means we need to set the punch and die. Simple thing. Next point is worn out punches affect the quality of tablets, like increase of variation of mask, reduce surface shininess. Next is variation in length of entire set, that also leads to varying variability in tablet batch. Compression forces affect the dissolution properties of the tablet. So dissolution properties is the main reason why uh, we should do the tablet tooling. Next type, these are the types of tablet tooling: B, D, double B, DB. So coming to types of tooling B, so here punch diameter is 19 mm, die diameter is 30.15 mm divided by 1.187 inch, and punch length is 133.60 mm per inch. Next year maximum tablet size should be around capsule, etc. And type D also it's mentioned, and BD also mentioned, DB also mentioned the same, like 25.4, 19, 25.4. Here also 38.1, 1.50, 24, then 0.945 and 3.15 divided by 1.187. And punch, I think everything is same punch length, and tablet size differs 25 by 25, 13 by 14 and 19 by 19. Next, here is a tablet tooling: lower punch, upper punch, and in the middle one die is there. So what it does? So it consists of a upper punch, lower punch, die, and king. So the upper punch has a shorter stem. The lower punch stem is longer because it travels longer distance up and down in the die for filling, compression, ejaculation or ejection of tablets, so thereby sealing the die hole formed below during entire process of compression. Next, this diagram explains about the tablet tooling from B, D, DB, all that things. Okay. Next, coming to coating of tablets. So what's coating? Coating is a manner by which a basically dry outer layer of coating material is implemented to the surface of a dosage form to achieve precise benefits. And coating may be implemented to a wide range of oral solid dosage shape, along with capsules, multiparticulars, drying crystals, and while coating composition is carried out to a batch of capsules in a coating pan, the tablet surface grow to be protected with a tachipolymeric film. So before the tablet floor dries, the carried out coatings adjustment from sticky liquid to semi-solid, and sooner or later to a non-sticky dry pans. So many stable pharmaceutical dosage forms are prepared with coatings, both on the external surface of the tablet or on substances dispensed inside gelatin tablets. Next, different methods of coating. First is sugar coating, under sugar coating, sealing, subcoating, syrup coating, coloring, polishing. First, sugar coating. What is sugar coating? It's originally developed from the use of sugar to mask taste and provide an attractive appearance to the core. So this process of the tablet coating consists of several steps that are described below. First is sealing. So what is a seal coat? It is uh, used for sealing of tablets. So what is how it is used? So it is applied over the tablet to prevent moisture penetration into tablet core. So shellac is a particle that was previously used as a sealant, but due to polymerization issues, it was replaced by gen. It's a kern protein derivatives. Next, coming to subcoating. So this step is done to round the edges and increase the tablet weight. So it is used generally to increase the weight of the tablets. Next, coming to syrup coating. The imperfections in the tablet surface are covered up and the predetermined size is achieved. So this step requires the maximum skill. So here, what it is done? Uh, it is used to give a predetermined stage, or it is used to give a proper size of the tablet. Next, coming to coloring agents. So it gives the tablets its artificial color. Means we can color the tablet according to ourselves. Next, coming to polishing agent. Example is beeswax, canaba. That is a that is a provided desired. It is applied to provide a desired luster. So tablet surface is get polished. Okay. Next, coming to film coating. So what's film coating? As the sugar coating process is very time consuming and dependent on skills of the coating operator. So film coating has been replaced by sugar coating. So this process involves spraying of a solution polymer pigment plasticizer onto a rotating tablet bed to form a thin uniform film on the tablet surface. The choice of polymer may depend on the desired site of drug release, like stomach, intestine, heart, chest, all that things. So, or on the desired release rate. So, next, some of the non-entericotic polymers are hydroxyl methyl cellulose (HPMC), and next methyl hydroxyl cellulose, next ethyl cellulose, then next is povidone, while the commonly used enteric-coating polymers are cellulose acetate, acetate phthalate, and acrylate polymers like udrazid L, udrazid S. So again, coming to HPMC, uh, phthalate, etc. So an ideal film coating material should possess the following characteristics. First, it should be soluble in solvent of choice. Second is it must produce an elegant coat or good coating material. Third is it should be stable in presence of heat, light or moisture, and it should not possess the disagreeable color, taste or odor. Next is it should be non-toxic and pharmacologically inert. Means it should be absorbed by the body. Next, coming to tablet coating process. This is the diagram that explains. First is uncoated core, then then coating pan is there, then uh, peristaltic pump is there, then organic solvent or aqueous dispersion is passed through it, then the inlet air, outlet air. some air pressure is generated, then the coating is done to the tablet core. Again, the finished tablet uh, is uh, brought outside the body or outside the coating pan. Next, coating composition. First, coating composition is applied to the moving bed tablets. Next, heated air is introduced like inlet air and outlet air. First, in inlet air heat is applied. Next, some the solvent which are absorbed by the tablet are evaporated. So it is so tablet compression is accomplished by the movement of tablets in perpendicular or vertical direction to the application of the coating composition. Next, these are the equipment that are used for tablet coating. First is standard coating pan, second is perforated coating pan, third is FBC, fluidized bed coater. Here is the example of standard coating pan. So we will go through some standard coating pan. So it's known as conventional pan system, and it's mounted angrily on a stand, and its diameter is 8 to 60 inches. It's rotated on a horizontal axis by a motor, and the heated air is introduced into the pan and onto the bed surface, and it's adjusted by the means of ducts through the front of pan. Next, coming to perforated pan, here is the diagram that describes the perforated pan. Okay, so it is perforated or partially perforated drum, like drum shape is there. So next is rotated on its horizontal axis in an enclosing housing. And the third is the coating solution is applied to the surface of the rotating bed of tablets through spraying nozzles which are present inside the drum. And next is perforated pan coaters are efficient drying system with high coating capacity. Last is perforated coating system. What does it contain? Contain a Acela coater system, high coater system, dry coater system, glad coater. So, Eclaquota system here, inlet air is passed, then mixing blades are there, and the tablet is placed, and one spray gun is introduced into the coating pan, and the just air passed through it. So, here also coating is possible. Okay. So next is high coater system. Here also you can see the diagram. As a tablet bed is there, pan with perforated plates. There some plates are there. There blades were there. Here plates are there. Again there is some air supply is there. Then an exhauster is there to uh, evaporate the air and evaporate the moisture of the air. And next, spray gun is also introduced. Okay, so next, hectacota and high quota system. First, here the dry air is directed into the drum, passed through the tablet bed, adjusted through perforation in the drum. So dry quota system, here you can see the spray gun is there, and one adjuster is there inside, and the coating pan is there. After that, perforated ribs or rubbers like rubber shape elements are there. Okay, so next coming to what is it that it does here, drying air enters through the hollow perforated ribs located on side of periphery of the drum. Next, as the coating pan rotates, the ribs and deep into the blade bed, and drying air passes up through exhaust is formed to back of the pan. So exhaustion is possible through back of the pan. Next, coming to glad coater. Here is the diagram glad coater. Okay. So it is the latest pan coater to be introduced in the industry, and uh, so in this drying air can be directed from inside the drum through tablet bed. Next, it is exhausted out through an exhaust duct. So last of all, coming to the fluidized bed coater. Wow. So here, fluidization of the tablet mass is achieved in a columnar chamber by the upward flow of drying air, and the air flow is controlled so that the more air enters the center of the column, causing the tablets to rise in the center, and the movement of tablets is upward through the center of the chamber. Okay, so here the movement of the tablet is upward. So thank you for listening me. If any doubt is there, then you can ask me freely. Okay. Thank you. Have a nice day.